Today, on how it's made. Umbrellas. Outboard motors. Silver cutlery. And tape measures. It provides shelter from the rain, protection from the sun, and it's a chic fashion accessory. The umbrella originated in ancient China some 1,700 years ago. Since then, it's evolved from the original parasol to the modern-day collapsible canopy. Unlike mass-produced models, this quality umbrella is meticulously crafted by hand. Production begins with a birchwood shaft, which an artisan stains to match the umbrella's handle. He narrows down the shaft so it will fit perfectly into the handle. After buffing the handle to a shine, he glues it onto the shaft. Next, the artisan forms two springs from wire made of nickel silver, a metal that can withstand extreme tension. He bends one end of the wire into a triangular shape and hammers it flat to ensure a neat fit. He cuts two slots in the shaft, one at the top and one at the bottom. Then he pierces each slot, creating a hole for the spring to hook into. With a bit of stain, he hides the exposed wood. For the umbrella to open and close easily, the springs must fit snugly, so the end of the spring gets a right angle bend. This shape sets the correct tension. With a tap of the hammer, the springs now rest firmly into the slot. After trimming the spring, the artisan forms it into the perfect shape by purposely overbending, then correcting the position. A small pin inside the shaft prevents the spring from opening fully. This brass runner is what you slide up the shaft to open the umbrella. A stop pin limits the runner's travel, preventing the canopy from blowing inside out. The artisan fits a length of tying wire around a slot in the runner, then threads the canopy's 8 ribs onto it. The ribs are made of a type of steel that's strong yet flexible, so they curve into a dome shape when the umbrella is open, then straighten out again when it's closed. The rib's other ends are wired to what's called a notch. Once they're in place, they'll rest just below the handle line. At the spot where the notch will sit on the shaft, a hole is drilled. This will hold the pinning wire in place. Workers cut 8 triangular-shaped panels called gores from durable nylon. They attach a label, then assemble the canopy by sewing all 8 gores together. Next, 8 metal tips are inserted into a machine that wraps them in fabric. Then they're stitched to 8 locations inside the canopy. These smaller pieces of fabric, called prevents, stop the canopy from chafing against the frame. This decorative rosette hides the point at which the runner and ribs meet. Next, the canopy is draped over the shaft and hand-sewn tightly over the notch. A tip is attached over the end of each rib. Then each rib is aligned with a canopy seam. After checking the fabric for imperfections, a worker secures the ribs in position by sewing them to their respective seams. They roll up the umbrella to check that the fastening button and band, attached earlier, are in the right place. A decorative ring goes over the notch. Then the top of the shaft is crowned with a ferrule. a brass cap with a protective steel tip. This company embellishes its shaft with a steel-plated band, ideal for engraving the owner's initials. After a quick wash, the canopy is ironed for a neat, crisp finish. The final touch is a matching cover, which you can slide off in an instant if you're caught in a sudden shower. When we return, an inside look at the outboard motor. Generally smaller than their inboard counterparts, outboard marine motors come in a variety of sizes and horsepowers, ranging from single-cylinder models to powerful 8-cylinder configurations. They can run on gas, diesel, or electricity, and they can provide power for a quiet day of fishing or an exhilarating offshore drag race. Outboard motors have an engine on top and a gear case below. This aluminum engine block is the skeleton that houses the cylinders, the heart of the engine's internal combustion system. Under a stream of cutting fluid, machines hone the cylinders to precise dimensions. Minuscule X's are carved into the steel that lines the cylinder walls. Oil will settle into these X's, keeping the walls well lubricated for the piston. Workers assemble each piston manually. First, they build a ridged bearing and insert it into the loop at the end of a connecting rod. Then they fit the rod into a piston head, securing it with a pin. The pistons are placed in the cylinders. Then they lower the engine's crankshaft into place and attach it to the loops at the ends of the connecting rods. The crankshaft's bearings are lubricated and capped off. Then this part of the engine is sealed with an aluminum cover. To get the cover's positioning just right, the first bolt is driven into place manually. A precision torque wrench does the rest. Now the top is screwed on. A magneto system is mounted onto the crankshaft. As it spins, it generates electricity for the engine's electronics and pumps. Meanwhile, on another assembly line, the gear case takes shape. This machine locks the case's forward gear to a shaft that'll turn the motor's propeller. The propeller shaft connects the lower drive shaft. The factory buys these pieces ready-made from a supplier, but still has to refine the dimensions so that everything fits together perfectly. This machine analyzes the shaft. It concludes that this one needs to be a fraction of an inch longer. So workers add the required number of steel discs, called shims. They insert this drive shaft into the gear case, then attach the propeller shaft with the forward gear. Now the gear case is linked to the drive shaft, which connects to the propeller shaft, which turns the propeller. The next piece to go into place is the middle section of the motor, the part in between the engine and the gear case. First, workers attach the gear case, now fitted with a shift rod for switching gears, and an upper drive shaft, which transfers power from the engine to the propeller. Next, the unit gets a coat of paint that's saltwater resistant. When the paint's dry, workers bolt the engine on top of the assembly. The engine is plugged into a master computer which automatically uploads an operating system onto the engine's internal computer. Then using a scanner, they input information about each cylinder. The motor is now fully operational. Workers insert a propeller onto the propeller shaft, then lower the motor into a test tank. This factory tests every motor it produces. They run the engine for about 10 minutes while a computer analyzes the performance data. After drying the engine thoroughly, workers apply the finishing touches, starting with the two-part cover that encases the lower portion of the motor. Then they latch another cover over the engine and stick on decals. Both covers are made of heavy-duty plastic coated in paint that won't fade, even after a lifetime of sun, wind, and water. Up next, turning out the silverware that turns an ordinary dinner into something special. Cutlery dates back to the Stone Age, some 300,000 years ago. Prehistoric people made the first cutlery from splinters of stone, shells, horn, and wood chips. During the Bronze Age, humans found a better material, metal. Forks came along much later, originating in ancient Greece. Whether cutlery is sterling silver, silver-plated, or stainless steel, the production process is the same. It all starts with thin sheets of metal. As workers manually feed the sheet through a press, a die inside punches out utensil shapes called blanks. Fork blanks go into a piercing tool which slices away 3 strips of metal. This creates 4 prongs with a support bar across the top for now. Meanwhile, spoon blanks go into a machine called the cross roller, which expands the spoon head sideways, thinning out the metal at the same time. Then it's into a clipping tool which trims the spoon head to precisely the right size and shape. Both spoon and fork blanks now go into a grinding machine that smooths away rough edges by vibrating them against small plastic cones. Elsewhere in the factory, a specialized tradesman sculpts the steel die that'll stamp the pattern on the cutlery handles. Working from a designer's illustration, he has to interpret the pattern in 3 dimensions. This requires tremendous skill because the depth of the design varies throughout the handle. He measures these minute variations with a tool called a micrometer. In the press, the die does 3 things: emboss the pattern, gently bend the handle, and mark the back of the utensil with the manufacturer's name. Now, back to the head of the utensils. The forks go into a press that bends the prongs to the right curve. Now that support bar can finally come off. Spoons, meanwhile, go into a press fitted with what's called a bowling die. It strikes the spoon's flat head into a bowl shape. Every time you strike metal, it hardens a bit. So repeatedly during the shaping process, workers have to heat the blanks to soften them again. Making knives is more complicated than making spoons and forks. Each knife handle is constructed from 2 halves. A press punches them out and stamps the pattern. Then a clipping machine removes excess metal around the perimeter. Now workers coat the edge with flux, a chemical cleanser. The surfaces have to be spotless to bond properly. The 2 halves are wrapped together with string. Then, powdered metal is poured into the cavity. It immediately sticks to the flux on the edges. The excess is discarded, then the handles are run through a mini furnace for 12 minutes. The 1600-degree heat liquefies the metal powder, soldering the 2 halves together and burning off the string. After polishing, the solder line will be invisible. Workers pour cement into the center of a centrifuge machine and load the hollow handles all around. As the machine spins, it fills each handle with cement. Now, each handle gets a stainless steel blade. The blade's stem goes directly into the wet cement, and a clamp holds the parts together during the hardening process. A 12-minute bath in hot water cures the cement, making the handle blade connection rock solid and giving the handle weight. For worker safety, it's only now near the end of production that they sharpen the blades. A good polishing, and this elegant silverware is ready for even the most sophisticated dinner party. Coming up, a factory that goes the whole 9 yards. A popular tool. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.